November 8, 1942. Richmond, California. Kaiser Shipyard, Number 2. A crowd gathered along the waterfront. Reporters, photographers, military officials, shipyard workers. They came to witness an attempt at what seemed impossible. Henry Kaiser, the brash industrialist from California who'd never built a ship before the war started, had made an audacious claim. His workers could construct a complete cargo ship in less than 5 days. Not assemble pre-made components. Not finish a partially completed hull. Build an entire ship from steel plates to finished vessel. A Liberty ship. 10,441 tons displacement. 441 feet long. 57 feet wide. Capable of crossing the Atlantic Ocean with 9,000 tons of cargo. A full-size, ocean-going merchant vessel. In less than 5 days. The experts were skeptical. Traditional shipbuilding took over a year from keel laying to launch. The best shipyards in the world, using conventional methods, needed many months at minimum. British yards building similar ships averaged 6 to 8 months. Even American yards that had adopted some modern techniques were completing ships in 42 days on average, which was already considered revolutionary. 5 days seemed physically impossible. There weren't enough hours. The work was too complex. Ships had too many components, too many systems that needed assembly, testing, integration. You couldn't rush certain processes. Welding took time. Piping installation took time. Electrical systems took time. Engine installation and testing took time. Kaiser disagreed. His workers had been preparing for this attempt for weeks, prefabricating components in unprecedented detail, planning every step, practicing coordination between teams. They believed they could do it. Kaiser certainly believed they could do it. He'd bet his reputation on it. Sunday morning, November 8th, 7:30 a.m. The work began. By Thursday afternoon, November 12th, 4 days, 15 hours, and 29 minutes after the first steel was laid, the SS Robert E. Peary slid down the launching ways into San Francisco Bay. Complete, functional, ready for sea trials. The crowd erupted in cheers. The record was official. 4 days and 15 hours. The fastest ship ever built in human history. And it wasn't a small boat or a simple barge. It was a 10,000-ton cargo ship capable of crossing oceans. 4,800 miles away, in Germany, Admiral Karl Dönitz commanded the Kriegsmarine's U-boat fleet. His submarines were sinking Allied cargo ships faster than Britain could replace them. Or so German intelligence believed. The Battle of the Atlantic was being won by Germany through simple mathematics. Sink ships faster than the enemy can build them. Eventually, Britain starves and collapses. Then, intelligence reports from America started arriving. Reports that seemed absurd, impossible. Clearly propaganda or miscalculation. America was supposedly building cargo ships at rates that defied belief. Not dozens per year, hundreds per year. Multiple ships per day across all American shipyards combined. Dönitz rejected the reports initially. Intelligence had made errors before. These numbers couldn't be real. No industrial capacity could build ships that quickly. Germany's best yards took months per ship. Britain's yards were similar. America couldn't possibly be 10 times faster. But the reports kept coming. More ships. Always more ships. The numbers were staggering. They had to be wrong. America must be lying about production to intimidate Germany and boost British morale. Dönitz was wrong. America was building ships exactly as fast as the reports claimed. Sometimes faster. The Liberty ship program represented American industrial capacity at its absolute peak, and it was about to turn the Battle of the Atlantic from a German victory into a catastrophic German defeat through pure, overwhelming production. This is the story of the Liberty ships, how an industrialist who'd never built ships revolutionized shipbuilding, how America applied automobile mass production techniques to constructing ocean vessels, how the Battle of the Atlantic was won not through superior tactics or technology, but through building ships faster than Germany could sink them, and how a speed record set in 4 days and 15 hours symbolized American industrial might that Germany simply couldn't comprehend or match. The story begins not in 1942 but earlier, when Britain stood alone against Nazi Germany and desperately needed cargo capacity. By late 1940, Britain faced an existential crisis. German U-boats were sinking merchant ships faster than Britain could replace them. Every sunken cargo ship meant lost food, fuel, weapons, raw materials. Britain was an island nation, dependent on imports for survival. If the shipping tonnage declined enough, Britain would be starved into surrender without Germany ever needing to invade. The numbers were grim. German U-boats were sinking Allied ships at accelerating rates. Britain's shipyards were building replacements as fast as possible, but traditional construction methods were too slow. A cargo ship took 8 to 12 months to build using conventional techniques. By the time a replacement was launched, several more had been sunk. Britain approached America for help. Could American shipyards build cargo ships for British use? America wasn't in the war yet, but the Roosevelt administration was sympathetic. Under Lend-Lease, America could provide material support to Britain. The challenge was American merchant shipbuilding capacity. America had shipyards, but most were designed for naval vessels or specialized ships. Few were set up for mass production of standardized cargo vessels. Building ships the traditional way wouldn't solve Britain's problem. Traditional methods were precisely why Britain couldn't build replacements fast enough. America needed a revolutionary approach. Someone who could think differently about shipbuilding. Someone who could apply industrial mass production principles to an industry that had remained largely artisanal and traditional. Enter Henry J. Kaiser. Kaiser was a controversial figure, a West Coast industrialist who'd made his fortune in construction, roads, dams, bridges. He'd worked on the Hoover Dam and the Grand Coulee Dam. He understood large-scale construction projects, heavy machinery, coordinating thousands of workers. He was aggressive, ambitious, confident to the point of arrogance. But he'd never built a ship. Not one. He knew nothing about maritime architecture or naval engineering. The established shipbuilding industry viewed him as an outsider, an amateur, someone who didn't understand the complexities of ship construction. Kaiser saw opportunity. The government needed ships, lots of ships, quickly. Traditional shipbuilders said it couldn't be done faster. Kaiser thought they were wrong. He believed shipbuilding could be revolutionized using principles from other industries. His insight was simple, but profound. Treat ships like automobiles. Henry Ford had revolutionized automobile production decades earlier through standardization and assembly lines. Before Ford, cars were built individually by skilled craftsmen. Each car was unique. Production was slow and expensive. Ford standardized components and created assembly lines where workers repeated specific tasks as the product moved past them. The result was dramatic increases in speed and dramatic decreases in cost. Kaiser proposed applying these principles to ships. Standardize the design. Every ship identical. Prefabricate large sections in advance. Assemble sections using standardized procedures. Use welding instead of riveting for faster construction. Employ unskilled or semi-skilled workers who could be trained quickly rather than relying on traditional shipwrights who took years to develop expertise. The established shipbuilding industry was horrified. Ships weren't cars. Maritime construction required craftsmanship, expertise, understanding of stresses and forces unique to ocean vessels. You couldn't mass-produce ships like consumer goods. The idea was absurd, but Kaiser had political connections and persuasive confidence. He secured contracts to build ships using his proposed methods. The government was desperate enough to try unconventional approaches. If Kaiser's methods failed, at least they'd tried. If they succeeded, they might solve Britain's crisis. Kaiser established shipyards on the West Coast, Richmond, California, and Portland, Oregon. He recruited workers aggressively. Many had no shipbuilding experience. Some had no industrial experience at all. Women, minorities, people who couldn't get jobs in traditional industries. Kaiser didn't care about background. He cared about willingness to work and ability to learn. The ship design was deliberately simple. The British had provided plans for a basic cargo vessel, reliable, unsophisticated, adequate. Nothing fancy. No advanced features, just a functional cargo ship that could cross oceans and survive normal conditions. The design became the Liberty ship. Kaiser's team made modifications for mass production, simplified where possible, standardized components extensively. Every ship would be built from identical parts using identical procedures. Workers could be trained on specific tasks rather than needing comprehensive shipbuilding knowledge. The prefabrication approach was key. Traditional shipbuilding constructed vessels in place, building up from the keel in the shipyard dry dock. Kaiser's approach prefabricated large sections away from the dock. Hull sections, deck sections, superstructure components. These were built in assembly areas, then moved to the dock for final assembly. This parallelized the work. Instead of one team building the ship sequentially, multiple teams built different sections simultaneously. When sections were complete, they were welded together. The final assembly was fast because most work was already done. Welding instead of riveting was crucial. Traditional ships were riveted. Metal plates fastened with thousands of individual rivets, each one requiring skilled labor and time. Welding was faster, not as proven in shipbuilding, and there were concerns about structural integrity, but it was dramatically faster. Kaiser recruited welders and trained new ones. Many women became welders, Rosie the riveters, though technically they were Rosie the welders. The workforce expanded rapidly. By 1943, Kaiser's Richmond yards employed over 90,000 workers. The first Liberty ships took longer than hoped. Learning curve was steep. Coordination problems emerged, but each ship was faster than the last. Average construction time dropped from several months to 2 months to 42 days. 42 days became the new standard. Revolutionary compared to traditional methods. Still not fast enough for Kaiser. He believed they could go faster, much faster. The idea of a speed record emerged. Build one ship as fast as physically possible to demonstrate what could be achieved with perfect coordination and preparation. Not sustainable for every ship, but proof of potential. The attempt was scheduled for November 1942. Shipyard No. 2 in Richmond would make the attempt. The ship would be named SS Robert E. Peary, after the Arctic explorer. Preparation was meticulous. Every component was prefabricated in advance. Every team rehearsed their tasks. The sequence was choreographed like a theatrical performance. This team installs the keel. Then immediately that team begins engine mounting, while another team raises hull sections. The attempt began Sunday morning, November 8, 1942. Cameras recorded the effort. Reporters documented progress. The entire shipyard focused on this single vessel. The speed was astonishing. Hull sections went up in hours. By Monday, the basic hull shape was recognizable. By Tuesday, The superstructure was being installed. By Wednesday, engines were being tested. By Thursday afternoon, the ship was complete. 4 days, 15 hours, 29 minutes. From first steel to finished ship. The SS Robert E. Peary was launched November 12th. She underwent sea trials and was commissioned into merchant service. She wasn't just a demonstration. She was a fully functional cargo ship that would serve throughout the war. The record made international news. 4.5 days. A complete ocean-going cargo vessel. The shipbuilding world was stunned. Even people who'd followed Kaiser's progress couldn't quite believe it was possible. In Germany, reactions ranged from disbelief to alarm. If America could build ships this fast, even as a record, even if not sustainable for every vessel, it meant American production capacity was beyond anything Germany could match. And the speed record wasn't just a stunt. Average Liberty ship construction time continued dropping. By 1943, ships were being completed in 30 days or less on average. Some yards finished ships in 2 weeks. The production volume was staggering. Numbers tell the story. In 1941, a handful of Liberty ships were completed. In 1942, production accelerated. By 1943, American shipyards were launching Liberty ships at an average of 3 per day. 3 complete cargo ships every single day. In 1943 alone, American shipyards delivered over 1,000 Liberty ships. 1,000 ships in 1 year. That's nearly 3 per day, every day, all year long. By the time Liberty ship production ended in 1945, America had built 2,710 of them. 2,710 cargo ships. Each one 10,000 tons displacement. Each one capable of carrying 9,000 tons of cargo across any ocean. If you could somehow line up all 2,700 Liberty ships end to end, they'd stretch over 200 miles. The combined cargo capacity was over 24 million tons. The total tonnage represented more shipping capacity than the entire British merchant fleet at the start of the war. The cost per ship dropped as production scaled. Initial Liberty ships cost around $2 million each. By 1943, the cost was down to around $1.5 million. For a complete ocean-going cargo vessel, this was remarkably cheap. Compare this to German ship production. Germany's shipyards were building cargo vessels at traditional pace, several months per ship. Total German merchant ship production during the war was a fraction of American output. Germany was losing the tonnage war catastrophically. The Battle of the Atlantic's mathematics shifted dramatically. Early in the war, German U-boats were sinking ships faster than they could be replaced. The trend was unsustainable for Britain. If it continued, Britain would lose. But by 1943, America was building ships 3 times faster than Germany was sinking them. For every ship a U-boat sank, 3 new ships were launched. The equation reversed. Instead of shipping capacity declining, it was growing rapidly despite German attacks. Admiral Dönitz recognized the problem. German U-boat production couldn't keep pace. Even if every U-boat sank multiple ships, they couldn't sink enough to offset American production. The mathematics had shifted decisively against Germany. Dönitz needed each U-boat to sink more ships per patrol to maintain the necessary sinking rate. But convoy tactics were improving. Escort vessels were more numerous. Radar and sonar were better. Aircraft patrols covered more ocean. U-boats were actually sinking fewer ships per patrol as Allied anti-submarine warfare improved. The combination was fatal to German strategy. U-boats sinking fewer ships per patrol. Allied shipyards building more ships per month. By mid-1943, Germany was losing the Battle of the Atlantic. Not through dramatic naval battles or technological breakthroughs, through arithmetic, through production capacity overwhelming destructive capacity. The Liberty ships weren't glamorous. They were slow, cruising speed of about 11 knots, roughly 13 miles per hour. They were basic, no luxury, minimal comfort, purely functional. They were sometimes called ugly ducklings because they were boxy and utilitarian. But they worked. They crossed oceans. They delivered cargo reliably. They were produced in overwhelming numbers. That was enough. The ships weren't invulnerable. U-boats sank hundreds of Liberty ships. So did German aircraft, mines, and storms. The welded construction occasionally caused problems. Some ships suffered catastrophic hull failures when welded seams cracked in cold water. The stress fractures were serious enough that modifications had to be made mid-production. But even accounting for losses and failures, the program was wildly successful. The production rate so exceeded the loss rate that the net tonnage grew constantly. Even when a Liberty ship was sunk, 2 more had been launched to replace it. The human cost of the merchant marine was significant and often overlooked. Merchant sailors faced constant danger crossing Atlantic and Pacific. They were civilians, but they were in combat zones. U-boats didn't discriminate between naval vessels and cargo ships. Merchant marine casualties were proportionally higher than most military branches. But the ships kept sailing. Crews kept volunteering. The cargo kept flowing. Britain received food, fuel, weapons, vehicles, raw materials. The Soviet Union received massive aid shipments. North Africa and Italy campaigns were supplied. D-Day required enormous cargo capacity to build up forces in Britain. The Liberty ships made all of it possible. Without the cargo capacity, the Allies couldn't have sustained operations. Strategic bombing of Germany required constant supply of bombs, fuel, spare parts. Tank warfare required enormous fuel consumption. Artillery consumed ammunition at staggering rates. All of it had to be shipped across oceans. Germany understood what was happening but couldn't counter it. The U-boat fleet couldn't sink ships fast enough. German surface raiders were neutralized by Allied navies. German aircraft couldn't reach most convoy routes. Germany's own production capacity couldn't match Allied expansion. By 1944, the Allied supply situation was so robust that the main challenge was port capacity, not shipping. There were enough ships to move cargo, but ports couldn't unload them fast enough. This was the opposite problem from earlier in the war when shipping was scarce. The Liberty ships continued production through 1945. Even after victory in Europe, ships were still needed for Pacific theater and post-war reconstruction. The final Liberty ship was delivered in September 1945 after Japan surrendered. Post-war, the Liberty ship fleet had to be dealt with. Thousands of ships that were no longer needed for military cargo. Some were sold to civilian shipping companies. Some were given to allied nations. Some were scrapped. Many were preserved in reserve fleets, mothballed in case they were needed in future conflicts. The Korean War saw some Liberty ships return to service. The Vietnam War used a few. Some served as merchant vessels into the 1960s and even 1970s. The basic design was so robust that with proper maintenance, ships built in 1943 were still functional 30 years later. A few Liberty ships survive today as museum ships. The SS John W. Brown in Baltimore and the SS Jeremiah O'Brien in San Francisco are maintained in operating condition. They're the last 2 operational Liberty ships, preserved as historical artifacts and memorials to the merchant marine. Henry Kaiser became one of America's most prominent industrialists. His reputation as someone who could achieve the impossible was secured. After the war, he expanded into other industries: automobiles, steel, aluminum, healthcare. Kaiser Permanente, the healthcare organization, was founded by Kaiser to provide medical care to his shipyard workers. Kaiser's legacy in shipbuilding was profound. He demonstrated that traditional methods weren't the only way to build ships. Mass production principles could be applied to large, complex products. Prefabrication and standardization could dramatically increase speed and reduce cost. Modern shipbuilding incorporates many principles Kaiser pioneered: modular construction, extensive prefabrication, standardized designs. These are now industry standards. Kaiser didn't invent all these concepts, but he proved they could work at scale in shipbuilding. The Liberty Ship program influenced military thinking about industrial capacity. It demonstrated that production capacity could be decisive in warfare. Superior tactics and technology mattered, but if one side could produce 10 times as much equipment, the quantitative advantage often overcame qualitative disadvantages. This lesson shaped Cold War strategy. Both the United States and Soviet Union emphasized industrial capacity and production capability. The arms race wasn't just about who had better weapons, but who could produce more weapons faster. The Liberty ships also demonstrated the importance of merchant marine and logistics. Armies need supplies constantly. Running out of fuel, ammunition, or food can lose battles regardless of tactical skill. The ability to move cargo across oceans safely and in vast quantities was crucial to Allied victory. The SS Robert E. Peary, the record-setting ship, served until 1963. She made multiple Atlantic crossings during the war, survived several close calls with U-boats, and transported thousands of tons of cargo. After the war, she served in various civilian roles until finally being scrapped. 21 years of service from a ship built in 4.5 days. The speed record stood for decades. No cargo ship was built faster until much later, when different construction methods in different contexts broke the record. But in terms of traditional shipbuilding, constructing a complete ocean-going vessel in 4 days and 15 hours remains an extraordinary achievement. The workers who built the Liberty ships were diverse. Women comprised a significant portion: welders, electricians, pipe fitters, crane operators. African Americans worked in roles that had traditionally excluded them. The urgent need for workers broke down some discriminatory barriers, though certainly not all. Rosie the Riveter became an iconic image representing women in wartime industrial work. Though technically many were welders rather than riveters, the image captured real social change. Women demonstrated capability in roles previously closed to them. After the war, many women were pushed out of industrial jobs as men returned, but the precedent was set. The shipyards were dangerous. Heavy machinery, welding equipment, large sections being moved by cranes. Accidents happened. Workers were injured or killed. The push for speed sometimes led to safety shortcuts. Unions fought for better conditions, but wartime urgency often overrode safety concerns. Despite dangers and difficulties, morale was generally high. Workers understood the importance of their labor. Every ship launched was a ship that could supply Allied forces, bring a soldier home, or weaken Germany's blockade. The work was meaningful, and that sustained motivation. The Liberty ship production demonstrated American industrial culture at its peak. The combination of immigrant labor, women entering workforce, mass production expertise, engineering innovation, and organizational capability created something unprecedented. No other nation matched it. Germany's industrial capacity was substantial, but it was organized differently. German production emphasized quality and precision. German engineering culture valued sophisticated, well-made products. This produced excellent tanks, aircraft, and weapons, but it meant lower production volumes. American production philosophy was different. Make adequate products in overwhelming quantities. The Liberty ship embodied this perfectly. It wasn't the best-designed cargo ship, It was adequate. But America built 2,700 of them. One adequate ship serves its purpose. 2,700 adequate ships win wars. Germany kept trying to win through superior technology. The Type 21 U-boat was far more advanced than anything Allies had, but only a handful were operational before war ended. Technology advantage was meaningless when you couldn't produce enough units. The Liberty ship program cost approximately $13 billion total for the entire production run. The Manhattan Project, developing the atomic bomb, cost about $2 billion. America spent 6 times more building cargo ships than developing nuclear weapons. This reflected strategic priorities. Nuclear weapons ended the war dramatically, but cargo ships sustained the war effort daily. You needed both, but the unglamorous logistics ships were arguably more important for most of the war. The psychological impact on Germany was significant. German leadership watched American production figures with growing alarm. How could one nation build so much so fast? What kind of industrial capacity did America possess? The numbers suggested something beyond Germany's ability to comprehend or counter. Some German leaders recognized early that America's industrial potential made victory nearly impossible. But Hitler refused to accept this. He believed German will and fighting spirit would overcome material disadvantage. This was a fatal miscalculation. The Liberty ships became symbols. To Americans, they represented industrial might and determination. To Allies, they represented hope and supply. To Germany, they represented an enemy with seemingly unlimited resources. The program wasn't without critics. Some argued the ships were too basic, too slow, too vulnerable. Some questioned whether Kaiser's methods sacrificed quality for speed. The structural failures from welding problems seemed to validate these concerns. But the numbers spoke clearly. The program worked. The ships served their purpose. The production rate was sustained. The Battle of the Atlantic was won. Critics couldn't argue with results. After the war, assessments were more nuanced. Yes, welding problems caused issues. Yes, some ships failed catastrophically. Yes, the basic design had limitations. But the program achieved its strategic objective, providing enough cargo capacity to supply Allied forces and sustain Britain through the blockade. Perfect was the enemy of good enough. The Liberty ships were good enough, and there were enough of them to accomplish the mission. The program's lessons extended beyond shipbuilding. It demonstrated principles applicable to any large-scale production challenge. Standardization enables scaling. Prefabrication parallelizes work. Simplified designs reduce complexity and training requirements. Worker motivation matters when the mission is clear. These principles influenced American manufacturing culture permanently. Post-war American industry was shaped by wartime production experiences. The expectation that anything could be mass-produced at scale became embedded in American industrial thinking. The Liberty ships represented a specific moment in American history. The combination of urgent necessity, available resources, organizational capability, and cultural factors that made the program possible was unique to that time and place. It couldn't easily be replicated, but it happened. 2,710 ships, built in the span of 4 years, with the fastest one completed in 4 days and 15 hours. An achievement that seemed impossible became routine. That's the essence of American industrial capacity in World War II. The Germans couldn't believe it. They couldn't comprehend it. They couldn't match it. And ultimately, they couldn't win against it. 4 days and 15 hours. That's how long it took to build a ship that would help win the Battle of the Atlantic and demonstrate that American industrial capacity was simply unstoppable. 4 days, 15 hours, 29 minutes. From first steel plate to completed ship sliding into the water. 10,000 tons, 441 feet long, ready to cross the Atlantic Ocean, carrying 9,000 tons of cargo. Traditional shipbuilding, 8 to 12 months. British yards, 6 to 8 months. American yards using new methods, 42 days on average. Henry Kaiser's record, 4 days, 15 hours. Admiral Dönitz read the intelligence reports and assumed they were wrong. America couldn't possibly be building ships that fast. The numbers made no sense. They violated everything German engineers understood about shipbuilding. But the numbers were real, and they represented something fundamental about American industrial capacity that Germany never understood until far too late. By 1943, America was launching 3 Liberty ships per day, 3 complete cargo vessels, every single day, all year long. Germany was losing the Battle of the Atlantic not because of tactics or technology, because of arithmetic, because America could build ships 3 times faster than U-boats could sink them. By 1944, Allied shipping capacity was actually growing despite German attacks. 2,710 Liberty ships total, $13 billion invested, 90,000 workers at peak in Kaiser's yards alone. The program cost 6 times more than the Manhattan Project. Because cargo ships don't win wars dramatically, but they sustain war efforts daily. The SS Robert E. Peary, the record-setting ship, served for 21 years. She crossed the Atlantic dozens of times, delivered countless tons of cargo, survived the war, proved that a ship built in 4 days could last decades. Henry Kaiser revolutionized shipbuilding by treating ships like automobiles. Standardization, prefabrication, assembly line methods, unskilled workers trained for specific tasks. The traditional shipbuilding industry said it couldn't be done. Kaiser did it anyway. The Germans never figured out how to counter it. They understood the principles intellectually, but they couldn't execute at American scale. Their industrial culture, their resource limitations, their strategic situation all prevented matching American production even if they understood the methods. 4 days and 15 hours. That's not just a shipbuilding record. It's a statement about industrial capacity that no enemy could match. If this story fascinated you, the industrial achievements, the production miracles, the capacity that overwhelmed enemies through sheer numbers, you're watching the right channel. Hit that subscribe button and turn on notifications. War Rewind uncovers the industrial might, the innovations, and the production capacity that actually won World War II. Not just the battles, but the factories that made victory possible.